Hello everyone. In this video, we are going to solve this problem. First, I will read this problem, then I will explain how to solve it. Find the power spectral density function whose autocorrelation is given by R double x of tau, which is equal to a square divided by 2 into cos omega naught tau. So here the question is autocorrelation is given. We are asked to find out what is the power spectral density. So listen. So to find out power spectral density, we need to know what is autocorrelation. In our previous video, we had solved a problem in the same type where autocorrelation is given in terms of with some interval. So by help of that interval, we have solved the problem easily. So look at this problem. In this problem, interval is not given. So suppose if the interval is not given, then how to find out the power spectral density function? By help of autocorrelation, that is we are going to see in this video. So first, write what is the formula to calculate power spectral density. So our formula to calculate power spectral density is S double x of omega. So S double x of omega is nothing but it is a power spectral density function. So to calculate this function, we need to know all these results. So R double x of tau, then e power minus I omega tau into d tau. So in our question itself, it has given what is R double x of tau. So R double x of tau, it is nothing but it is our autocorrelation function. So it is R double x of tau is equal to a square divided by 2 into cos omega naught tau. It is given. So here in this formula, in power spectrum formula, first substitute what is R double x of tau. From the question I have written what is R double x of tau. It is a square divided by 2 cos omega naught tau. After writing this, then write the remaining value. It is e power minus I omega tau into d tau. So now we are going to integrate these two parts. Before we are going to integrate these two parts, we have to check out whether it is in the easiest form or not. Because if our terms are in easiest form, it is very easy to integrate. Suppose if our integrating term means integrating part, are in difficult form, then it would be little bit difficult. Not little bit difficult, we need to apply number of formulas to integrate. To avoid such a situation, we are using some results. Okay, so that results will help us to solve the problems in a short way. So what result I am going to use here? So I know a formula. Cos theta is equal to cos theta is equal to e power I theta plus e power minus I theta divided by 2. This is our formula. So instead of cos omega tau, we can apply this formula. Here theta is going to be play as omega naught tau. So wherever we have theta in this formula, so there we have to replace theta by omega naught tau. So after so here for cos omega naught tau, I am going to apply this formula. So the formula is e power minus omega naught tau plus e power minus I omega naught tau divided by 2 into remaining e power I omega naught tau into d tau. So after substituting the results, let us move. After substituting the results, let us move to next part. So here, so I am just going to expand this term into two parts as it is in the u plus v into multiplication form. So 1 by 2 here. Here 1 by 2 is constant, so that can be outside. When we take 1 by 2 outside, so it will become 1 by 4 because already we have 2. So 2 into 2, it is 4. The remaining part, this part and this part can be multiplied with this one, and it can be separated into two parts. So I am going to separate in two parts by multiplying this one with this one. So after separating, I am getting this step. So look at here. Here we are having two terms in terms of E. Okay, so in terms of E, so these two functions, so if base are same, then we can add the power. So by that rule, I just have added the power because bases are same in both part. I just have added the power. So when while I'm adding the power, I'm just checking whether there is any common term or not. In first step, in first part, minus I and tau is common, so that can be taken outside from the omega minus omega naught. Similarly, in second part we are having minus I and tau, that also can be taken outside. So what is the remaining part? So remaining part, I just have the remaining part I just directly have given the results, because by using Dirac delta function we have a result. So whenever we have minus infinity to plus infinity e power minus I omega tau into d tau, for that results, if you want to integrate this function, then we can directly apply this results. Okay, so here we have this is first part, and this is this is first part, this is second part. In both part we are having in the same structure, so we can apply the results. So after applying results, then we can directly simplify it. So after simplifying, we are getting our results. This one. So thank you so much. We will meet in next video.